Hi, my name's Damon and I'm the lead product trainer for SoundOff Signal. Today, I'm here to talk to you about our new 100J Siren speaker. The 100J is jam-packed, full of new technology. It has a stylish new design. It fits the majority of our vehicle's speaker brackets, and it's louder. Additionally, it's field serviceable, so you can take it apart at your shop and perform repairs on it. It's really not that hard. Give us a call, we'll walk you through it. In fact, let's take one apart right now. Okay, so we're in the shop now. Let's start talking the tools it's going to take to do this job. Now I've got a nice list of tools here. We're going to go over each one, what you're going to need to use it for, and we'll talk about that as we build or take the speaker apart. But probably the most important tool that you can have right now is coffee. You got to have some coffee while we're doing this. If you're an upfitter and you don't drink coffee, you're probably doing it wrong. So, all right, let's talk about the different tools. So the first tool you're probably going to need is going to be a set of flush cutters, okay? Any brand will do, just some sort of flush cutters to cut the wires and obviously take care of any zip ties that might be on the wires. Next, you're going to need a set of wire strippers, all right? That's going to be for any kind of wire stripping. You might need some crimpers as well. I don't have them here, but these two tools here and the crimpers, those are likely to be necessary if you do end up having to cut into the speaker wires or the harness somewhere along the line. Now, the next tool, and probably the one we're going to use the most, is the multimeter. We're going to use this predominantly on the ohms ranging to determine the different levels of resistance along the wires as we're testing the speaker. We'll also need a 10 millimeter ratcheting wrench or a 10 millimeter wrench or a 10 millimeter ratchet. Now, I've got an impact here. I'm going to use this in the video. I stress to you, be careful when it comes to impacts. Use them slowly, light. Most of these impacts have a torque setting on the top. Make sure you set it on the lowest torque, just so you don't pull the threads out of the screws that we're working with. And the last thing you're going to need is a set of channel locks or cobras or pliers or something like that. And these are pretty small if you look at them. But something like this to basically, when we get to the point where we're undoing the thumb nuts, we want to have this to give us a little bit more torque. All right. So let me set up the stage and we'll start tearing down the speaker. All right, so here we are. We've got the speaker ready to start testing. Now I've got it on the bench. I'm doing a bench test. It actually allows me to isolate a problem specifically to the speaker. There might be an issue inside the speaker versus an issue in the wiring, and by bench testing it, I'm able to check that a little bit easier. But that does require cutting the wiring and removing the speaker from the vehicle. Now, if you wanted to do it on the vehicle, you can do that as well. But the first thing you have to do is we've got to ohm out the speaker. We've got to make sure that we've got the proper resistance. So I'm showing 4.4 ohms, which is a good number. This is a 4 ohm speaker, so that's putting me right in the right range. We might have a little bit more or less depending on the leads on your meter. Now, if you wanted to do this in the car, you're going to need to basically, you either leave it connected and you test it all the way from the siren, which is beneficial because if you can test it all the way from the siren and you're getting a good reading, well, that's indicating that there's nothing wrong with the speaker or the wiring. But if you're getting a bad reading, like it's showing 0.1 or 0, that's showing that you've got a short circuit, which could be in the speaker or could be in the wiring. But if you're getting a high reading, that could indicate that you've got high resistance, possibly something like a corrosion in the wiring. It could be corrosion at the connectors, and that's usually where all the corrosion occurs, is anywhere you make a connection. But it also could occur anywhere somebody's poked a hole in the wire. That's going to eventually start to corrode. Copper doesn't really like oxygen too much, so it starts to oxidize rather rapidly. But if you had something like the aftershock, which is our low frequency siren, well, that actually goes in line on the speaker. So you've got the wire coming out of the speaker, and then it goes into the aftershock, and then from there it goes to the speaker. And that's going to give you a very high impedance rating or resistance. You're going to see a super astronomically high number in that case. So the cool thing is if you've got a 480 siren amp and you've got a aftershock siren speaker or a low frequency speaker, it comes with a T-harness. You can just unplug the T-harness and then you're back to just testing the line between the speaker and the amplifier at that point. So if we've determined, for whatever reason, we've determined that this speaker is actually no good, or we think it's no good, we need to open it up and actually test it on the inside. So only these 4 bolts are what need to be removed. So I'm going to go ahead and pull those off. Okay. Try not to lose too much of the hardware. It happens. I'm going to disconnect this for a couple minutes, get it out of the way. Now, I like to keep my hardware all nice and tidy, and when you work on a clean bench, or organized bench, I should say, it's a lot easier to find stuff as you're working on it. So once those are out, it's time to remove the back cover. Now, the thing about the back cover is the wire that's coming through the back cover is almost the same diameter as the hole in the back cover. And I'm going to zoom in on that so you can see. It's a pretty tight hole. So in order to get this off, I'm actually going to push the wire through as I lift the cover off. It's easier than it sounds. If I was doing this on the car, like it was still hooked up or the bracket was still mounted on the car, that might get a little bit more difficult. It's not impossible. It takes probably a couple more minutes. Unless, of course, you're taking the fascia off, in which case it might take quite a bit more time. All right. So once I've got the horn off, we're down to just basically this next cup. I'm going to go ahead and pull this cup off. Exact same thing. I'm going to kind of feed that wire through as I pull it off. Now, there's a gasket here. When you get a new driver, it's going to come with a new gasket. Use the new gasket, okay? All right, so we're down to the actual driver at this point. Now, if you notice, I'm keeping everything in this vertical line, and I'm trying not to spin things as I take it apart because I don't want to change the clocking on the actual driver. The reason being, the driver has SoundOff signal in a specific direction. Okay, so now we're at that point where we could actually test the driver. Now, if this was connected to the car and we had a short circuit somewhere, whether we were trying to determine if it was in here, or we were trying to determine if it's at the amplifier or somewhere in between, we need to take these thumb nuts off. That's what this little tool comes in for. Pop those off. Now, I'm disconnected from anything right here, so I'm only going to pull off one. But we would pull both these off. And grab our meter again. And give it another test. And there's that magic number again, 4.4. That's good. Now, if we did have a short, and it actually was here, it's probably going to show a really low reading. Or it may show a high reading, indicating there's some internal resistance. Either case, we're gonna, we'll help you getting through it and getting it taken care of. All right, so I'm gonna go ahead and disconnect that and go ahead and put this back together. Now, part of the reason I had you check this also was to rule out a bad connection here, because if we had a bad connection here or somewhere between here and our next connection, taking it apart helps us rule that out. Just one more little troubleshooting tip. All right, so we tighten this back down. Tighten it up a little bit. It doesn't need to be super tight, just snug. And then it's time to move this guy back on. And again, as Ace Ventura used to say, it's like a glove as far as how tight it is. I'm holding that gasket in place. The new gasket's got a little stick to it, so it's not going to do that. Quite a bit in there. And there we go. Okay, do the same thing with this one here. Start hand threading these. Just make sure they're starting to thread on their own, and then use your impact and remember to put it on its lowest setting. Or you can do it by hand. And I'm just going to run them up until I feel it start to do its impact thing. And I'm going to finish them off with my ratcheting wrench. If you've ever taken a wheel off of a car before, do it in that same pattern where you're doing them at 180 degrees and then you flip 90 and do it 180 again. All right, so once you've tightened everything down, we're going to use the meter one more time. Just check everything out. Make sure we didn't pinch a wire when we put it back together. So, showing 4.4 again. That's good. I think we're just about done. Now it's just a matter of putting everything back together on the car. You might need to reconnect this if you did a bench test on it like I did. And that's it. All right, well, till next time.